So for activity number 3, the number 1 is a shaft has 4 discs A, B, C, and D along its length 100 millimeters apart. A mass of 0.8 is placed on B at a radius of 20 millimeters. A mass of 2 kg is placed on C at a radius of 30 millimeters and rotated 120 from the mass on B. Find the masses to be placed on A and D at a radius of 25 millimeters that will produce total balance. So, to find the balance of disc A and D, we will first make a table. So, M is for the mass, R is for radius, MR, X is for distance, MRX, angle, MRX cosine theta, and MRX sine theta. So, for disc A, the mass of disc A is not stated in the problem, so we will find it later. And for disc B, the mass is stated in the problem 0.8 on B, and for C is 2 kg, and for D it is not stated in the problem, so we'll find it. And for radius, the radius of disc A is 25. It is stated in the last part of the problem, 25 millimeters. For B is 20, C is 30, D is 25. So the MR is, in getting the MR is, we will multiply the mass and the radius. So that for disc A, since there is no mass, we will copy the 25. For B, 0.8 times 20 is 16. 2 times 30 is 60. There is no mass on disc D, so copy 25. For X, it is the distance, so the length apart away is 100 millimeters. So our reference is the disc A. We will start from A and we will add 100 millimeters apart. So 0 for A, for B is 100, C 200, D 300. So for the MRX, we will multiply the MR and D distance. So 25 times 0 is 0, 16 times 100, 1,600, 60 times 200 is 12,000, 25 times 300 is 7,500. So for the angle, for disc A, there's unknown angle. So, and for B is 150. So how did we get 150? So in the problem, it is stated that at a radius of 30 millimeters and rotated 120 from the mass on B. So 120 plus 30 is equals to 150. So this is angle form for disc B. So C is 30, D is unknown. So for cosine, 0 for B is negative 1385.6, for C is 10,392.30, and D is negative 9,006.7. So for sine, same formula situation, the 1,600 sine 150, 800. For C is 6,000. For D is negative 6,800. So in making it balance, we will assume a number to get it to make it balance, to make it 0. So for the cosine, we will get the D, so unknown. So the angle is unknown, so we will assume a number that will make it 0 to make it balance. So the negative 1,385.6 plus 10,392.30 is equals to 9,006.7. So to make it 0, we will add it negative 9,006.7 to make it 0. So the same in sine. 800 plus 6,000 is equals to 6,800, and to make it 0, we will add negative 6,800. So for the resultant, MRX for D is equals to 9006.7 multiplied by itself plus 6800 multiplied by itself, and square root, and the result is 11,285.92 kilogram millimeters. So the value for D, so 7,500 is equals to mass of D is equals to 11,285.42 11,285.42 divided by 7,500 is equals to 1.5 kilogram. So the mass of the disc D is 1.5 kilogram. So the tangent 6,800 divided by 9006.7 is equals to 37 degrees. So the true angle theta is since the total degree is 180, so add it, and 37 degrees, 180 degrees plus 37 degrees is equals to 217 degrees. So the angle for this D is 217. So for the disc A, the same formula or situation. We will make first the table to find the mass and the angle. So MA 25, 0.8 to 1.5, 20, 30. So the same with this in getting the mass and the angle of disc D. So the resultant MR vector is 8.14 multiplied by itself plus 15.4 multiplied by itself square root is equals to 17.42 kilogram millimeters. So and 17.42 divided by 25 is equals to 0.696 kilogram. So for the mass for disc A is 0.696 kilogram, and A is equals to 0.696 kilogram. So this is the mass of disc A. So for the angle, the tangent -1, 15.4 divided by 15.4 divided by 15.4, no, 8.14 divided by 5.14 is equals to 62 degrees. So the true angle is, the total angle is 180 degrees plus the angle 62 degrees is equals to 242 angle. So the angle for disc A is 242 degrees, and the mass is 0.696 kilogram. So that is for number 1. So for number 2,